At Modular Plywood Industries, innovation meets craftsmanship in every step of the plywood production process, ensuring top-quality products. The journey begins with peeling, where logs are rotary cut into thin veneer sheets, each layer meticulously prepared. These sheets are then dried to an optimal moisture content, ensuring stability and durability. Moisture checking is critical at this stage to maintain consistency and prevent warping during production. Next, glue testing ensures the adhesive used meets the highest standards, providing a strong bond between layers. Glue spreading follows, where the adhesive is evenly applied to each veneer layer before they are carefully assembled into a stack. The core assembling phase involves placing a central layer, which adds strength and stability to the final plywood. The stacked layers are then subjected to the hot press process, where heat and pressure fuse the veneers together, creating a solid sheet of plywood. After pressing, the plywood undergoes a DD show, double density, ensuring uniformity and strength. The sanding process smooths the surface, while polishing enhances the finish, giving the plywood its refined appearance. To improve the surface quality further, the plywood is dipped to seal the wood and is then brushed to remove excess coating. Rigorous inspection ensures every sheet meets the stringent quality standards, and sample checking is conducted for consistency across the batch. Finally, the plywood is ready as finished products, ready for use in various applications, from construction to furniture, showcasing the precision, sustainability, and innovation embedded in every piece. Amara's purpose-built production facility in Portsmouth is designed to deliver high-quality dorsets tailored to a variety of sectors, including airports, healthcare, education, and commercial spaces. The process begins with heavy-duty FSC door cores, which are precisely cut to specified dimensions. FSC hardwood lippings are then bonded to the core, followed by the application of 0.7 mm thick laminate or veneer facings, which are pressed onto the core for a durable finish. Using state-of-the-art CNC machines, Amara's team meticulously machines each door's features, including vision panels, hinges, concealed overhead closers, and recesses for push and kick plates. The doors are grooved for intumescent seals and undergo radius machining as needed. Each door is carefully sanded to precise tolerances, grain-filled for a superior finish, and coated with a hard-wearing lacquer that is UV cured for added durability. The glazing beads are hand-sprayed, mitered, and assembled using special dovetail joints. Production is monitored closely to ensure quality control, with 2 CNC routers in operation to meet demand. Skilled craftsmen guarantee an unrivaled finish, and protective packaging ensures safe storage and installation on site. Amara's expertise in fire-resisting, soundproof, and security doors ensures compliance with the highest standards. The manufacturing process at Schuf's Fensterbau, Germany is characterized by precision, efficiency, and a commitment to premium quality. Established over 90 years ago, the company specializes in producing wooden and wood-aluminum windows, doors, sliding doors, and conservatories. Production takes place in 4 state-of-the-art halls equipped with modern CNC machines. These advanced machines ensure high accuracy and efficiency while allowing for a diverse and customized product range. Skilled carpenters oversee every step, guaranteeing meticulous craftsmanship. The production process begins with material selection, focusing on sustainably sourced wood for its natural warmth, durability, and excellent thermal insulation properties. The wood is cut, shaped, and processed into various profiles such as classic, landhose, and historic, each catering to specific architectural styles and functional requirements. The company also offers specialized profiles for energy efficiency, noise reduction, and historical preservation. Once the profiles are crafted, the assembly process integrates components such as glass panes, decorative elements, and hardware. Special coatings and treatments are applied to enhance durability, weather resistance, and aesthetic appeal. For doors, a blend of wood, glass, and metal achieves a modern yet robust design, with custom finishes available for individual preferences. Final inspection and testing ensure each product meets SCHUF's rigorous quality standards. The result is a range of highly customizable, environmentally sustainable, and aesthetically versatile products designed to meet modern and traditional architectural needs. Finally, after the modules are joined, the focus shifts to finishing touches, completing the interior and exterior to perfection. This efficient, modern process delivers durable, cost-effective homes while offering customers unparalleled convenience and peace of mind. Expert Maison has transformed home construction with its innovative modular manufacturing process. By prefabricating homes in a controlled factory environment, the company ensures superior quality, reduced timelines, and a stress-free experience for customers. This approach simplifies construction by delivering pre-built modules directly to the site, where assembly occurs within a single day, leaving only interior and exterior finishing work. The process begins with model selection, where customers choose from a range of expertly designed homes tailored to their needs and budget. Expert Maison provides a detailed cost estimate based on the selected design and materials. Next, in the material selection phase, the team pre-selects interior and exterior finishes to align with modern trends and ensure availability, minimizing potential delays. During pre-production, the architectural team finalizes plans, incorporating customer preferences and project requirements. Customers approve the plans before production begins. In the factory production stage, each module is built with precision, adhering to stringent quality standards. The completed modules are then delivered to the construction site for rapid assembly. McGuigan Furniture specializes in crafting high-quality furniture that blends durability and craftsmanship, exemplified by the creation of a deep button-back restaurant chair. From raw timber to the final upholstered product, every stage of the manufacturing process is carried out with precision and care by a dedicated team of 30 skilled workers. Machining department. The process begins with rough planks of timber, which are meticulously cut, sanded, and jointed using mortise and tenon techniques. Assembled frames are reinforced with corner blocks for added strength and stability. Attention to detail and quality control are paramount at every stage to ensure a robust foundation. Spray and finishing department. Furniture pieces are polished in a range of 15 standard colors or customized to match specific client requirements. Custom samples undergo a rigorous matching process to ensure consistency, though slight variations may occur between batches. Each piece is finished with a protective and aesthetically appealing polish. Steel and welding department. For fitted seating, steel is cut, welded, and shaped using CNC benders to create sturdy frames. Frames and cast iron bases can be powder coated in any desired color, ensuring both durability and visual appeal. Sewing department. Fabrics and leathers are precisely hand-cut and tested on chair frames to ensure a flawless fit. Fine details such as piping, double stitching, buttoning, and diamond stitching are meticulously checked for perfection before proceeding. Upholstery department. The final stage involves web weaving, foam testing, and expert upholstery. Client specifications are brought to life with bespoke details such as deep buttoning and studding, ensuring both comfort and visual elegance. The construction process with Gablok begins with the placement of the foundational series of insulated wooden blocks. These blocks are lightweight, weighing approximately 7 kilograms each, allowing for easy handling without the need for heavy machinery. The blocks are designed for perfect interlocking, similar to assembling a piece of furniture, making the process straightforward even for those without prior construction experience. Each block is guided by a detailed plan that specifies its exact position, ensuring precision from the outset. Once the foundational blocks are in place, the rest of the ground floor structure is completed. The Gablok system's modular design simplifies this stage, ensuring rapid progress without the usual construction delays. The detailed architectural modeling allows for predetermined placements of openings such as doors and windows, reducing the need for on-site adjustments. The third day focuses on receiving the structural components required for the floors. These include laminated wooden beams for extended spans, such as open spaces and window bays exceeding 1.5 meters. The beams are engineered to support the weight of the upper floors, ensuring structural stability. The flooring system is composed of wall plates and joists that interlock using a dovetail mechanism to form a robust framework. This prefabricated system, designed to C24 resistance class specifications, ensures durability and ease of assembly. By the end of this day, the entire floor framework is in place. The flooring elements are secured and finalized, creating a solid base for the construction of the first floor. The process follows the same modular approach, making it quick and efficient. The lightweight and precisely designed blocks ensure that construction remains straightforward and manageable. The first floor is then completed using the same interlocking block system. The modular approach ensures consistency and minimizes errors. The structural elements, including beams and floor elements, are seamlessly integrated to prepare for the next stage, the roof installation. Gablok, a complete construction system. The Gablok system is engineered for speed, accessibility, and durability, making it a standout choice for modern construction. It uses eco-friendly materials like EPS, 98% air and 2% matter, and OSB, which reduce the carbon footprint. These materials are recyclable and reusable, promoting circular construction practices. The blocks provide superior insulation with a U value of 0.15 W per square meter K, ensuring energy efficiency and compliance with EPB standards. Gablok adapts to various architectural designs, offering blocks in multiple sizes and configurations to meet specific project needs. Additionally, the prefabricated system eliminates material wastage, ensuring a clean and efficient building site. Gablok's components. Gablok offers a range of components, including general insulated blocks, insulated starter blocks, beams, floor elements, internal walls, and upper and lower laths. General insulated blocks are available in 3 sizes and are the most commonly used in the construction process. These blocks are made of OSB and EPS, ensuring lightweight and robust construction. Insulated starter blocks are designed to fit perfectly onto the base wooden lath, forming the foundation for the structure. Beams constructed from laminated wood are used for long spans and to support upper floors. The floor system is composed of prefabricated elements that interlock to form a stable structure. Pre-assembled kits for interior walls are delivered to the site, ready for on-site assembly, while upper and lower laths serve as the structural base and upper reinforcement for the wooden block system. Social and environmental impact. Gablok's lightweight blocks, e.g., 8 kilograms for C600 blocks, improve working conditions by reducing physical strain and enhancing safety. By eliminating the need for water, sand, or cement, Gablok reduces the environmental impact of construction. The inert and stable nature of EPS ensures it has no adverse effects on the environment. Gablok is committed to achieving carbon neutrality and addressing the social and environmental challenges of modern construction. Advantages of the Gablok system. The Gablok system offers numerous advantages. The final stage involves installing the roof frame. The innovative design of the Gablok system allows for quick assembly, ensuring the roof structure is both durable and accessible. This stage marks the culmination of the primary construction, leaving only the finishing touches to be applied. Its modular design and prefabricated components allow for rapid construction, enabling a 100 square meter structure to be completed in just 5 to 6 days. The interlocking design and comprehensive plans make the system accessible to both professionals and amateurs. Detailed architectural modeling ensures all components fit perfectly, reducing the need for on-site modifications. The system minimizes labor costs and eliminates material wastage, offering significant savings. Additionally, high-quality materials and innovative design ensure the longevity of the structure. The CMS Aries 5-axis CNC machine is a high-speed, integrated machining center designed for complex wood processing, such as volutes and stair treads. It features a robust and precise structure, ensuring rigidity and exceptional movement dynamics, which are critical for maintaining high precision over time. This advanced machine is ideal for applications in industries demanding high-quality finishes and accuracy, such as aerospace and motorsports. Equipped with large working areas, the Aries offers substantial flexibility, enabling various configurations like single-zone or pendular cycles. This adaptability allows for continuous machining, maximizing productivity. The machine's design ensures high performance and accuracy, with a 23% improvement in machining precision compared to industry standards. The Aries also integrates CMS adaptive technology, which optimizes material removal parameters for specific surfaces. By simply selecting the relevant mapping, operators can reduce cycle times on complex surfaces without sacrificing finish quality. This results in enhanced productivity and reduced operational costs. The machine's electro spindles, fully designed and manufactured within the SCM group, offer a wide range of power, torque, and speed options, ensuring suitability for diverse machining needs. The flexibility to combine milling and ultrasonic cutting units further enhances performance, particularly in the machining of core materials, creating synergy between the two technologies. The Gemini wood carving duplicator is a versatile tool designed for precision woodworking. It allows users to duplicate both 2D and 3D shapes with ease, making it ideal for creating items like guitar bodies, necks, violin plates, cello components, duck decoys, furniture legs, moldings, and more. The machine can replicate intricate designs, including those found in stringed instruments, using an existing template as the reference. Equipped with an optional rotary fixture, the Gemini machine can handle complex three-dimensional shapes, ensuring high accuracy and smooth carving. Its rigid structure and balanced design provide superior control, making it easier to work with delicate or detailed wood pieces. The machine's operation is simplified through a patented brake mechanism, which stabilizes the cutting motion, preventing errors and ensuring a consistent finish. Gemini's carving machine produces highly accurate duplicates that require only minimal sanding, saving users time and effort in the finishing process. The machine's straightforward setup and ease of operation make it an essential tool for both professional woodworkers and hobbyists looking to create precise, high-quality wood pieces quickly. The Tormat Smart is a state-of-the-art 5-axis CNC machining center designed for wood lathe operations. It integrates various processes, including rough turning, gouging, and surface milling, to achieve high precision and efficiency. The machine's operations start with rough turning using a shaper to shape the initial contours, followed by detailed turning with a gouger for fine shaping. Surface milling can then be performed using either the shaper or an electrospindle, providing versatility for different finishing needs. Additionally, the electrospindle enables mortising, making the machine suitable for intricate woodwork. One of the standout features of the Tormat Smart is its automatic tool changing system with a 5-position magazine. This enables seamless transitions between various tools, eliminating the need for manual adjustments and allowing for complex milling tasks in a single setup. The machine also supports quick program changes, making it highly efficient for both serial production and custom orders. The process begins with log scaling, where incoming logs are measured and graded to determine their volume and quality. Logs then pass through the debarker, where bark is removed, leaving a clean surface for further processing. Smaller logs proceed directly to a single pass saw, converting them into lumber in a single operation. Larger logs are handled by the head rig, which breaks them down into manageable sections before being further processed. For finer cuts, the resaw is employed to refine the dimensions of the lumber, while the curve gang saw maximizes yield by cutting along the natural curve of the wood. After primary sawing, the edger trims the edges for uniform width and smoothness. The sorted lumber is then directed to the bin sorter, separating pieces based on size and grade. To prepare for drying, the lumber is placed in the sticker stacker, which spaces boards to allow proper airflow. Next, the stacks are transferred to dry kilns, where controlled heat and humidity remove moisture, ensuring stability and durability. After drying, lumber is processed in the planer, which smooths the surfaces and refines dimensions. At this stage, grading specialists assess the lumber to assign grades based on appearance and structural quality. Boards are trimmed to specified lengths in the trimming step and marked with a grade stamp, signifying compliance with industry standards. The lumber is then organized in the sorter and prepared for shipment using the stacker and bander, which secure the bundles. Finally, the lumber is wrapped in protective paper, tagged for identification, and staged for shipping to customers. This comprehensive production process ensures consistent quality and meets the diverse needs of industrial, export, and specialty markets. Collins Lakeview Sawmill's dedication to sustainability and customer service reflects its commitment to long-standing relationships and environmental stewardship. By utilizing advanced processes and FSC-certified practices, the mill produces premium softwood products with minimal environmental impact, ensuring a reliable and responsible source of lumber for various applications. The construction of a wooden house, particularly using the post and beam method, involves a meticulous and well-coordinated sequence of steps to ensure a durable and aesthetically pleasing structure. This method is characterized by its open spaces and visible wooden framework. The process begins with the fabrication of wooden frame walls, using spruce joists and assembling window frames. Oriented strand board is installed for bracing, followed by a weatherproof membrane and an anti-rodent grill. The outer cladding is then affixed to protect the structure. Completed panels are carefully stored on lifting beams to maintain their integrity. For the structural framework, post and beam preparation involves cutting beams to precise dimensions and creating dovetail joints in load-bearing beams to house floor joists securely. The mortises are drilled into the main beams for assembly, ensuring a solid connection. Once prefabrication is complete, the components are transported to the construction site. The assembly begins with adjusting the bottom sill and erecting the walls and the main post and beam framework. The floor joists are set in place, followed by the assembly of the roof structure. Insulation is installed in the roof, achieving a watertight and airtight structure. The next stage involves interior insulation and finishing touches, such as the installation of a vapor barrier to regulate humidity and ensure energy efficiency. These steps result in a robust, weather-resistant home that offers excellent thermal performance. This harmonious blend of craftsmanship and precision showcases the enduring charm and functionality of traditional wooden house construction. The construction of a timber frame house begins with the preparation of the foundation. Accurate groundworks ensure the stability and durability of the structure. Once the foundation is completed, the timber frame is prefabricated off-site, often using locally sourced and sustainable wood such as Douglas fir for its structural elements. This prefabrication process ensures precision and efficiency, reducing on-site construction time. The frame is then assembled on-site, starting with the vertical wall panels, which are secured to the foundation. These panels are typically pre-insulated with eco-friendly materials such as wood fiber or cellulose. Once the walls are erected, horizontal beams and roof trusses are added to complete the structural skeleton. Next, the house is enclosed with a weatherproof membrane to ensure airtightness, a crucial aspect of modern energy-efficient construction. Exterior cladding, often wooden siding, is then installed. Internally, additional insulation and airtightness layers are applied to enhance thermal performance. Windows and doors are fitted, and interior partitions are built. Finally, plumbing, electrical systems, and finishes such as flooring and cabinetry are installed. This process ensures a high-performance home that meets strict thermal and environmental standards, often qualifying as passive houses or BBC, Bâtiment Basse Consommation, certified buildings. Wood frame ecological houses are gaining popularity for their many advantages. They are environmentally friendly, quick to construct, durable, and aesthetically pleasing. This type of house is built using a wooden skeleton structure, also known as a wood frame, which forms the core support of the building. The framework is composed of vertical studs, horizontal beams, and cross members, all aligned with precision to ensure stability and strength. Sustainable materials such as laminated wood and oriented strand board are often used, offering excellent resistance and reliability. These materials are sourced responsibly, frequently carrying certifications like FSC, which guarantees sustainable forest management practices. Construction is tailored and handcrafted on-site based on detailed designs from engineering studies. The use of French-origin timber further enhances sustainability. With precise assembly and innovative techniques, wood frame houses deliver superior comfort and ecological benefits. Building a wooden extension for a four-facade villa involves several well-planned steps to ensure a durable and functional result. The process begins with installing the leveling beam, which provides a stable and even base for the structure. This step is crucial for ensuring the integrity of the entire extension. Next, the wooden structural boxes are assembled and positioned to form the framework of the extension. These elements are then connected to the main building using a connection beam, ensuring seamless integration between the new structure and the existing home. Once the framework is secure, the roof parapets and sheathing panels are installed. These components provide stability and prepare the structure for the flat roof. Following this, the flooring is laid to create a solid foundation for the interior space. The flat roof is then constructed, paying close attention to ceiling and drainage. A protective tarp is placed over the roof to shield it from weather during the construction process. To ensure the extension is watertight, flashing is installed where the new structure meets the existing building. Finally, cellulose insulation is blown into the walls and roof, providing excellent thermal performance and energy efficiency. Meunier Frères is a leader in sustainable construction and renovation. They specialize in wood framing, roofing, extensions, insulation, cladding, terraces, and chalets, delivering high-quality, lasting results for every project.